In section 2.3, we'll be solving quadratic and cubic equations, and there's a couple of different ways we can do this. However, when we only have one variable occurrence, that means we only see the variable x one time in our equation, we can solve for the real solution just by using inverse operations or by getting that x by itself. So for example, in this first one, 2x squared minus 1 equals 7, I only see this variable x occur one time in the solution, meaning I'm just going to use inverse operations to get that x by itself. To do that, I'll start by adding 1 on both sides. Then get 2x squared equals 7 plus 1 is 8. Then I'll continue by dividing by 2 to get x squared equals 8 divided by 2 is 4. And finally, I have to remember that the inverse operation of squaring is square rooting. So when I do that, I get x equals, remember, both positive and negative 2. Whenever you take a square root, you're going to have two solutions, positive and negative. For the next one, again, I only see this x one time in my equation, so I can use inverse operations. I'll start by adding 1 to both sides to get 2 times the quantity x plus 4 squared equals 6. Then I'll continue by dividing by 2. And I'll get x plus 4 squared equals 3. Then at this point, I need to undo this squaring on the outside of the parentheses, so I will end up square rooting both sides to get x plus 4 equals plus or minus square root of 3. I'm going to leave this in radical form because I don't really know what the square root of 3 is off the top of my head. It's an irrational number. It's not a nice number. It's a decimal that goes on forever and ever and ever. So I'm just going to leave it instead as the square root of 3. But again, I know that once I take the square root, I have two solutions, one positive and one negative. I look though when I see that this x is still not by itself. So my last step would be to subtract 4 on both sides. So now again, I notice that this square root of 3 and this 4, again, I don't really know what the square root of 3 is, so I'm just going to leave my answer with the actual square root of 3 in it and say that x equals negative 4 from right here, plus or minus the square root of 3. Similarly for this next one, again, I only see x in one spot, so to get that x by itself, I'll start by dividing by negative 3, and I'll get x plus 4 squared equals negative 1. Then I'll take the square root, and I get x plus 4 equals the square root of negative 1. At this point, we ask ourselves what number times itself gives us this negative 1. And we have to remember that square roots of negative numbers do not exist in the real number system. So here we would write no real solution. Whenever you get the square root with a negative under it, we say no real solution. Moving on to the next row, here I have all cubic functions, still with just one variable occurrence. So for this one, I'm going to start by adding 10 on both sides. I'll get 2x cubed equals 16. Then divide by 2 and get x cubed equals 8. Now I have to remember what the inverse operation of cubing something is, and that's taking the cube root. So then I ask myself, what number times itself 3 times equals 8? And that number would be 2. 2 times 2 is 4, times another 2 is 8. So the cube root of 8 is just positive 2. When we take cube roots, we only have one solution. For my next one, I'll start by subtracting 5 and getting x minus 2 cubed equals negative 4. I'll cube root both sides and get x minus 2 equals the cube root of negative 4. I know some of you are tempted to look back up at this third example and write no real solution. However, we are allowed to take cube roots of negative numbers. I just don't really know what number times itself 3 times would give me -4. So I'm just going to leave this in the cube root notation. I'll add 2 and get x equals 2 plus the cube root of -4. Then finally for this one, I'll start by dividing both sides by 3 and get x cubed minus 10 equals 17. I notice now that there's nothing else on the outside of the parentheses, so I don't really need the parentheses anymore. I can still just focus on getting the x by itself by adding 10, getting x cubed equals 27, and then taking the cube root and getting x equals 3, since 3 times 3 times 3 is 27. For this next section, though, we talk about what happens when we have more than one variable occurrence. Meaning, for example, in this equation, I see the variable x show up 2 different times. When that happens, I can't really get x by itself without doing some other work first. So when this happens and I have 2 or 1 or more variable occurrence, I can factor and use the zero product property, or I can use the quadratic formula if it can't be factored. So what I'm always going to do first with these types of problems is see if I can factor. With x cubed minus 3x, if we think back to our last section of notes, this has 2 terms, so I'm going to see first if there's a GCF. With x cubed and -3x, I can factor an x out, and I'm left with x minus 3, and it still equals 0. So when I look at this, I now have something times something else equals 0. Whenever that happens, something times something else equals 0, one of those 2 things, one of those 2 factors that I'm multiplying has to equal 0. So we're going to split it apart by its factors and say that either this x equals 0 or x minus 3 equals 0. When I do that, this x setting it equal to 0 already gives me one of my solutions. And then with x minus 3 equals 0, all I have to do is add 3 and get x equals 3. That's again called the zero product property. So now trying another one, again I see that I have more than one variable occurrence. I'm going to try to factor it. This time, since there are 3 terms and there is no greatest common factor, I'm going to start by making my factoring x, looking for 2 numbers that multiply to -6x squared and add to -x. Those 2 numbers would be -3x and +2x. I want you to go ahead and pause your video now and see if you can continue to factor this. I'll factor using the think about it method, and then you can restart the video and check your work. So whether you factored by grouping or just kind of thought about what your factors would look like, you should have gotten 2x minus 3 times x plus 1 equals 0. If you had questions on how I factored that, either write those questions down and bring them to class, or go back and watch the 2.2 videos and see if you can figure out where you maybe made a mistake. So again, at this point, I have 2 factors that when multiplied give me 0. So from there, I'm going to say either 2x minus 3 equals 0, this first factor, or x plus 1 equals 0, and then solve for x in both of those much easier equations. Then finally for this last one, again, I notice that I have 2 variable occurrences, but the biggest difference between this third one and the first 2 is that this equation equals 3 and not 0. In order to try to factor and use the zero product property, this equation has to be set equal to 0. So to do that, I'm just going to move the 3 to the other side by subtracting it and get x squared plus x minus 3 equals 0. I see that I have 2 variable occurrences. There is no GCF, so I'm going to try to factor first and find 2 numbers that multiply to -3x squared and add to +1x. When I sit and think about that, I realize there are no two numbers that are going to work. So I have to use a different strategy, and that different strategy is the quadratic formula. We'll practice the quadratic formula in class, but you should remember from Algebra 1 that the quadratic formula is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And we fill those in to get our irrational solutions to this equation. You'll remember that a is the number in front of x squared, b is the number in front of x, and c is this number without an x. So we're going to go ahead and try to fill in our quadratic formula. For opposite b, in this equation my b value is 1, so I would put negative 1 plus or minus the square root of b squared, so 1 squared, minus 4 times a, which is 1, times c, which is negative 3, all over 2 times a, which is 1. Now we just work on simplifying. Negative 1 plus or minus, I'm going to work inside the radical first. I know that 1 squared is 1. And then if I think about these three numbers, negative 4 times 1 is negative 4. Negative 4 times negative 3 is positive 12. All over 2 times 1 is 2. And lastly, I know that 1 plus 12 is 13. From here, I ask myself if I can simplify the square root of 13. And it's not a perfect square, and there are no perfect squares that go into 13, so this is my final perfect beautiful answer.